Unit 3, Triangles. Preview video 3.5, Congruent Triangles. Take a moment, close your eyes. Taking a look here, preview video 3.5, Congruent Triangles. So our previous lessons, past couple of them, have been about triangle guts, meaning relationships within a single triangle. So for example, just as a reminder, some of those relationships was a median, vertex to a midpoint, that's a median. An altitude, vertex to a right angle, would be an altitude. A perpendicular bisector, so going through the midpoint at a right angle. And then an angle bisector, that'd be cutting an angle in half. So those are all different segments within a single triangle. We also talked about this relationship within a single triangle. If you have two equal sides, you have two equal angles. So most of the prior lessons were about relationships within a single triangle. The next three lessons are about relationships between triangles. We're going to be learning these vocabulary words: slide, flip, turn, translation, reflection, rotation, congruent, CPCTC, pre-image, image, corresponding, whole, and part. If we take a triangle, and I'd just like you to physically trace this triangle. Physically trace it. That's called a pre-image. And if you were to simply slide the triangle over, you have the exact same triangle. That's called the image. That slide, the fancy geometric word for sliding a shape around, sliding a shape would be translation. Now imagine you take a triangle, and I'd let you to physically trace this triangle. Imagine a mirror being here. If you were to have a mirrored image, or you were to flip that triangle over something, flip it completely over, that would be a mirrored image, a flip mirror. We call that a reflection. Your hands and your feet, when you put your left and right hand next to each other, or your left and right foot next to each other, your feet and your hands are reflections of each other. Then imagine that you have a triangle. Again, trace it please. Put a dot right here. And imagine you were to rotate around that center dot. Rotate like a turn. Rotate. Trace this. That turn is called a rotation. So a slide is a translation, a flip is a rotation, and a flip is a reflection, and a turn is a rotation. So you're going to take the image of R and translate it, reflect it, and rotate it. So translation is a slide, so it's going to be pretty much exactly the same shape. Reflection, imagine a mirror. Rotation, imagine if you were to put a dot there and rotate however many degrees. Let's say a 90 degrees rotation would look like this. 180 degrees rotation would look like that, but it's some version of a rotation. So I'd like you to pause the video and label each one, 1 through 6, either a translation, reflection, or a rotation. Pause the video. Okay, welcome back. Let's see how you did. This first one. Reflection, rotation, reflection, translation, reflection, translation. Now, when you move a triangle through any of these motions, what you end up with is two completely congruent triangles. So right here, the motion from, let me color code this for you, triangle BCD, the yellow triangle, to triangle RST. If you look carefully, what's the motion here? As you can see that this B goes with R, it's rotated this way. So that is a rotation. And whenever you go through any one of these three motions, you end up with what's called corresponding congruent parts. Corresponding, that means in the same position, congruent parts. So, for example, in this set of triangles, angle B and angle R are going to be congruent because one sweep, C matches with S, angle S, congruent, D matches with T. Now watch carefully here, B to C, that's going from 1 to double, matches R to S, 1 to double. So R to S would be the correct answer there. S to R would not be the correct answer. Let me emphasize why again. B to C. B 1 sweep, C 2 sweeps. You have to follow that same order. R 1 sweep, S 2 sweeps. So CD and ST. CD double to triple, S to T double to triple. D to B, triple to single, T to R, triple to single. So when you have completely congruent triangles, you're going to end up with 6 items which are congruent. 3 pairs of angles, 3 pairs of sides, a total of 6. You must correspond the congruent vertices. So what is the motion of the triangle from left to right? So the motion of this triangle compared to this triangle. If you look carefully, what's the motion? you see W rotated this way, so this is a rotation. So watch carefully. Triangle MLW, MLW, MLW. Notice the order. Single, double, triple. Has to be congruent to L, M, N. Single, double, triple. That's called a corresponding. Triangle L, M, N. Let's try another one. Ask yourself, what is the motion of the left triangle compared to the right triangle? I'm going to wait 10 seconds. I'd like you to try to fill in that blank yourself. 10. Check your work. That is a reflection. One way to tell a reflection is, imagine if I folded along that squiggle line. If you fold it, kind of like a old-time Valentine, you fold it. The corners and the hatch marks actually match. RQE, RQE, single, double, triple, single, double, triple. That's RQP, RQP. Now, when we are told that triangles are congruent, this is true. If you know that the whole triangle is congruent, such here, I tell you the whole triangle is congruent, then all the individual parts are congruent, which is referring to this list. The 3 sets of angles and the 3 sets of sides. That would be considered parts. If the whole's equal, the parts are equal. If the whole is equal, all the parts are equal. So if the whole triangle RQE is congruent to RQP, then I could say, for example, that angle E is congruent to angle P. That would be a whole, this would be a part. We have an acronym for this. You want to fill in these words. Corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. That's the acronym CPCTC. Corresponding parts of congruent triangles are congruent. What that communicates is if the whole triangle is equal, the parts are equal. It's like saying, if I have congruent hands, then each individual fingers are also congruent. There are 3 sources of what are called congruency freebies. That means they are always congruent, but never marked. Those are called congruency freebies. They are always congruent, but they're never marked for you. You have to spot them and mark them yourself. These 3 are vertical angles. If you see them, you should mark them and get in the habit, if you have a pair of angles, for every pair you put an A with a circle. That stands for a pair of congruent angles. Drop a side straight down. Try to make it straight. Like you to shade this triangle on the left. Stripe this triangle on the right. So this side that's shared by both triangles, it's like an apartment wall. it's called a reflexive side. It's going to be congruent to itself. So you hatch mark it and you put S for side. That is a shared side, which makes that side congruent to both triangles. I'd like you to trace this triangle here, the smaller one. Trace the larger one. Do it again. I'd like you to trace the smaller triangle. Trace it. Trace the larger one again. This angle here is shared by both the blue and the red triangle exactly. That angle is shared exactly. That's called a reflexive angle. So if you see that, you mark it and you put A for technically that's a pair of angles. It's a single angle shared by both triangles. That's called a reflexive angle. Again, these are called freebies, or I call them freebies. They're things that are always congruent but never marked. You have to mark it yourself. So we're going to find freebies and mark them down below. So right here, AB is a reflexive side, so hatch mark and a little S circle for side. Here you want to trace that small triangle, trace that overlapping larger triangle. You want to sweep that toe, if you will. That's a reflexive angle. Little circle for A for angle. Here you have a pair of vertical angles, which are always congruent. A little A for a pair of congruent angles. This page you're going to do on your own. Pause the video, restart when you're done, and check. Alrighty, students, you should have done this on your own. Now you're checking. What's the motion left to right? It's rotation. KSI is TUI. Down here, what were the freebies? Reflexive sides, vertical angles, and a reflexive angle. I suggest you take 1 minute and verbally recap what you have learned in this lesson.